Okay, so you are given a list of strings of same length words and a string target. So all of the words are of same length in the list of strings. Your task is to form target using the given words under the following rules. So we need to form a word target, and we have some rules. Target should be formed from left to right. To form ith character of target, you can choose kth character from jth string in words if target I is equals to words j k. Does this make sense? Uh, in easy language, it is saying that. Uh, so let's copy this question first so that I can write. Yeah. So yeah, these are the rules. So to form the ith character of zero index target, you can choose. Sorry, which was the rule that we were. Yeah. So target should be formed from left to right. To form ith character of target, you can choose kth character of jth string. So we have a list of strings 0, 1, 2, and let's say this is j. So we can choose any of the strings from this list of strings, any word, and we can choose the kth character. Let's say this is k. So what will be this character? Words of j k. I think this now makes sense. Once you use kth character of the jth string, you can no longer use the xth character of any string such that x is less than equals to k. So now from all of the string, we cannot use any character which is before this. So we can only go ahead. In other words, all the characters left or at index k become unusable for every string. Repeat the process until you form the target string. Notice that you can use multiple characters from same string in words provided the conditions are met. Return the number of ways to form the target, and we have to give the answer modulo 1e9 plus 7. Is the question clear? Okay. If it is not clear, read the problem statement again. It should not be that difficult. Let's move towards the solution. And first, let us try to build the intuition on how can we get to the solution. Okay. Now let's pictorially see. Uh, let us use this input. Okay, I'm not able to see any of it. Yeah. Mhm. Mm, yeah. So this is the input. We have three words: A, C, C, A, B, 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 C, A, C, A, and our target is ABA. So what we can do, we can select any of the words and we'll start from left to right. So K will have to select in this direction. So let's say we first select this A. So we need to match to this targets. Let's say we have this A, then we need B, so we can select this B. Notice that we cannot select this B because this is on the same column. So we need to increase the column after selection of every word. So we can select this B, and then we need an A. So we have here, we don't have any A. This A we obviously cannot select. So we can select either this or this A. I think this is clear. So now we have uh, one way and two ways. Now we have two ways, right? Now, other than that, we can select, if we don't want to select this B, we can select this B, and then again we'll have two more ways. So 2 plus 2. Okay. And yeah, so do we have any other B? We have this B. We can also select this B, but then we'll not have any A's. So that is not the valid solution. So Next we can select this A. So let's say we don't want to select this A now, so we can directly select this A, and then we'll have again one and two options. So again two more. And do we have any more A's? Yes, we have this A, but then we'll not be able to select this entire string. So now the answer is 6. Let's see if the answer was 6. Yes, the answer was 6. So I think now the problem statement must be very, very, very clear, right? Okay, so let us try to jump to the intuition. What can we develop, or how can we solve this problem? See, this is a very, like, if you have practiced enough dynamic programming, you must be aware that now, okay, this is a dynamic programming question. Because see, what we are essentially doing in the dry run also, we were selecting some A. So we are moving towards one column and we were either selecting A or not, right? Like we selected A, then we move ahead, and then we decided if we want to select B or not. So either we are selecting B, right? Either we were selecting B, or we were moving ahead, right? Or right. So basically we were skipping the column. So every time we were performing this operation, right? So we were selecting or not. This for this column, we were selecting or not. Move ahead, we selected or not, and then we finally reached this column. Okay, so this selection and not selection is a very common dynamic programming pattern, and I think if you are at this point, you are solving this question, you must be aware about that. Okay, and if not, then we will see how is this a dynamic programming question. First, let us try to find out all the ways, and let us try to code what we just did using the dry run. Okay, forget about DP. If you don't know about DP, let us forget about that and just directly try to code what we just solved. Okay, so what we were doing, we were reaching at this point and we were saying, okay, we want to select an A. Okay, we want to select an A. Do we have any A's here? Yes, we have. So either we can select an A or we can try to find it somewhere ahead, right? So either we can select an A or we can try to find somewhere ahead. So either select A or not. If we want to select A, then the next character that we are going to select is B. So we'll again move ahead and then we'll try to select B, or maybe we can choose to move ahead and select B from the next column. Right? How can we perform this using the code? How can we do this? See what we are doing. So we want to write a function which will know what element of this target string are we trying to find and at what column we currently are. All right. So what we'll do, let's say we are trying to find ith character of this target and we are at kth column. Okay, what we can then do, we can either select, if we are selecting, if we're planning to select, then we will move ahead with I plus 1th character. So like if we have successfully found A, then we'll move towards B, which is the I plus 1th character, right? So we'll then find I plus 1th character, and yeah, and we have to move ahead in the column also. Okay, so this is the case when we selected, and if we are not selecting, then what we'll do, the character will remain same because we need to find A first before moving to B, but the column can be increased. This is the case when we'll not select. So are we good with this recursive approach? If this is complex, I can write the code. Actually, I've already written the code for this recursive approach. Uh, but this will definitely give us TLE, because obviously, like, how many, like, there are, this is clearly exponential, right? Like, this is the structure that we are forming in this recursion. Like, for every computation, we have two recursive calls, then for that we have again two more recursive calls, and uh this is clearly a exponential time complexity. All right, now this recursion will have to stop somewhere. Where will we stop? Can we safely say that at the last if we are at the last index of the target and we are able to find that, which means that now we don't need to go ahead. Let's say we have ABA as our target and we are at the A and we found that A, then we don't need to move ahead. We already got our answer, right? Or to simplify this, what we can do, like, as we are selecting this, let's say we found A and we move ahead and we know, okay, with the target string is now completed. The target string is now complete and we are an index ahead. So if we reach here, then also, like, we can safely say, okay, this is our answer and we don't need to move ahead. Or what we can do, if let's say these words are of n length, we have CA and we reached n. This is 0 1 2 and this is n minus 1 and we reach n, which means, and still we are not able to find the character of target, which means that this is not a feasible case, and we again need not go ahead, because we are already ahead of the final index of the word. So can we say these two are the cases where we can stop our recursion? Yes, we can. And finally, what we need to return? We need to return how many ways are possible to make this target if we are at this position where we are at the ith element in the target, and we are at the kth element in the kth row in the words list. So we have these two cases. Can we return this selected plus skipped condition? Can we return these two? And what will be our base case? Base case will be if I is equals to target dot size, right? Then we can return 1, which means that we have completed this target, which means we got one case. Okay, this is one of the cases where how we can reach to this target. And if we if our k if our k becomes equals to length of whatever this length is, if we reach here, which means that we'll not be able to find the target, then we can return 0. Here we have 0 ways, here we have 1 way, and this is our recursive calls, and this is our final result. And we can start from 0th element and 0th column. This will be our answer. I think this is now pretty simple, right? This looks pretty simple now, right? I've already written this code. Can we just look at that? Yeah. So see, we have, okay, this function is important. I forgot to see. Hmm. Let me just explain this too. Okay. See. So let's say we are trying to select C character from this particular column. So we need to know how many C's are there in this column. Does this make sense? We need to know how many C's are there in this column. So we need a data structure which will store that. So what data structure are we creating? We have A, B, C, D, E till Z. Here we will have list. Right? And this list will be in the first row, in the first column, how many A we have? 1. In the second row we have 1, then third we have 0, and then fourth we have 2. So now it will be easy if we have such a data structure, this will be easy for us to compute. Okay, we are trying to find a in the first row, we have 1a, then we have 1a in the second, we have 2a in the last. This is one data structure that we are initially creating. This will help us to uh, calculate the total number of possible words, that possible ways to generate the target word. So see what we have. We have a list of lists, and will have 26 lists, each corresponding to the character ABC to Z, and each character will have a list associated with it of length n. N is the number of columns, and this will have the value of how many, for example, how many that particular characters are there in ith row, right? So what we are here doing, we initialize this vector, and we'll uh, iterate through all of the words, and then for each of the word, what we are doing, we are finding the character. So what is this? This is character, right? Char Current character. How will we find the current character? We'll have word j, right? Word j is the current character. But if we want to but if you want to find which, like, what is the index of that particular character, for example, a, the index is 0, b index is 1, c index is 2, then we'll subtract this, and index will be current character minus a. Okay, and then we'll increase for that particular character, we'll increase the value of for jth row, right? We have n rows. For every row we'll have some characters, right? And this is how we are increasing. Try to write this on your own and it will be more clear. Okay, now then, we'll, as we discussed, that we'll start from f of 0 comma 0. So we are starting from 0 comma 0, we have a target and we have count. Then what we are doing, if we reach that size, then we'll return 1. We have one possible way. If we reach the end of the rows, like all the rows got completed, then obviously there is no way, then we'll return 0. Then we'll have two cases. This is case 1, where we'll skip this current row, and here is case 2. uh, Here we have case 2, where we'll pick the current row. So if we'll skip, then we will just increase the number of the index of the column, and the index of the target character will remain same. And what we'll do in the case where we are using the current row, if we are using the current column, then we'll try to see how many characters with ith index are here in the current column, right? And we will only be able to pick this current column if we have at least one of those, like at least one character, right? Let's say if we are trying to find a in this particular column, it is not possible because it is like we don't have any a's here. So we will only initialize the value of use if we have at least one character. Okay, if we have that one character, then we'll multiply the count, right? Then we'll multiply the count, and we'll increase the index of the target and the row as well, and then we'll mod. If you don't know about this mod, like what is this modular multiplication, then you need to study about modular operations. And once we are able to find this, then we'll add both of them and return. This will obviously give us a TLE, which means that we need to which means that we need to optimize this, right? I'm surprised how 50, almost 50 test cases passed. But yeah, okay. And then now comes the part where dynamic programmings come into the picture. So if you are well aware of how dynamic programming works, I would say that this much solution should be enough, and now you should try to write memoization or whatever you like, tabulation or anything by your own. And if you are not aware, then you can continue with the video. Okay, so how can we use dynamic programming here? So now we have this function, and we need to use dynamic programming. So try to find out what all values can we save, which can be used in the further computation. Can we see that we have two variables which are changing? Yeah, can we see that we have two variables that are changing? So it is very simple, like to write the memoization code. Especially writing memoization code is very simple. We can directly uh, start a vector or maybe dp array or whatever you like, right? And what will be the indexes, like what will be the size vector. The first one is the target, so we'll use m, and the next is the index of the column, which is, yeah, which is m, and plus one I'm doing because we'll be using 1 to n and 1 to m values. Okay, or either way, like if you are uh, using zero indexed arrays, that is up to you. Like you need to just add or subtract one on the basis of what size of the dp array are you taking. So we are currently taking this size. Okay, and you can pass this dp array uh, in the parameters. Wait, okay, let's just directly write the solution there only. Hmm. All right, and we need to initialize this array inside the main function. Okay, we haven't defined long. We'll have m plus 1. We'll have vector ll n plus 1 minus 1, and here we'll pass dp, and directly here we'll check if dp of I comma j is not equals to minus 1, then we can return dp of I comma j, else we can store it after computation. I comma j, right? Let's see if this is fine. Okay, we need to pass dp here and here too. I think this should be fine. Let's try to submit this. Let's see, a true DP lover never likes memoization solutions, right? It is always good to know how to write tabulation. So if you have done till here, I would highly recommend you to try to write tabulation solution, right? So yeah, first try, and then we will jump into it. So, and those who have no idea how to write tabulation can obviously continue with the video. Okay, yeah. So now we'll here make a table which we have already actually made, right? We have this data structure handy, which we will need definitely. And now we will, at last, our goal is to return dp of m comma n. dp of m comma n means how many ways can we form the target, and m is the last index of the target and n is the last index of the uh, like last row of the words list. All right. So the first thing that we do while writing a tabulation solution is writing the base case. Not just the tabulation, but also the recursive solution. First, we always try to write the base case. So what is the base case? Base case will be for the zero index, right? So see, for dp0, which means that empty target. So there is always one way to create the empty target, right? There is always a way to create an empty target. So for int I equals to 0, I is less than equals to n, I plus plus, we will write dp of 0 comma n is equal to 1. Okay, like, does this make sense? If this does make sense, then we'll now move forward and we'll fill all of the elements in the dp array. So see, this is a 2D array, so we'll need two loops, right? First we'll traverse the target. So we have m words in the target, and we have uh, n rows in the words list. All right. Now the first case was not using the current column, right? Not using the current column. And the second case was using the current column, right? If we are not using the current column, then what we were doing, if we are not using the current column, then we were just skipping it, and the current value will be same as the previous value, right? dp of ij will be dp of I j minus 1. This is, see, uh, this is bottom up approach. Tabulation is initially what we were doing was starting from 0, and then we were going there, and then we were returning 0 comma 0. But here what we are doing, we are returning m comma n. Okay. Now if we are using the current column, which means if we are using the current column, which means we'll have to add something from the previous one, right? We will have to add something from the previous one. So uh, first we'll need to see if we even have something in our data structure. Target I minus 1 because we are using 1 based indexing in our solution, but the target is actually 0 based. See, and similarly j minus 1 to see if we have something in the jth column or not. See, and if we do have something, then what? Then this means that now we will add the previous one, the previous answer, dpi minus 1, which means the previous index of the character, right? Previous index of the character into count of target I minus 1 minus a j minus 1, right? And dp ij mod equals to mod, right? This should be good. I think we did some mistake. We can check. uh, we initialized this. Oh, sorry, we need to initialize it 0, because like we are directly adding here, we need to initialize it with 0. Yeah. All right, we modified the base case. Okay, this will have 0 comma I, sorry for that. And yeah, should be good. Yeah. So as I was writing the code, maybe I wasn't able to properly explain the tabulation solution. Let me just go through the solution once more. So see what we did. We initialized. See, dpi comma dpij is returning a state where we are finding the number of ways to form target till ith index using first j rows of the words list. Okay, so for dp0, which means empty target, zero length of the target. See, empty target, forming empty target, we need one way, just one way, just skip the current row, right? So clearly this will be one. This is our base case, and then we'll move ahead. While moving ahead, we have two options. Either we can use the current row, or we can not use the current row and skip. So first is skipping. So if we are skipping the current row, which means that we are still at the ith uh, index, and as we have skipped the current row, so we will pick the result of the previous row and we'll copy it as it is. And secondly, we can choose the current column, which means we will take the result for the previous index of the target till the previous column, and we will multiply with that, and then we will mod, and yeah, this will be our final answer. Yeah, I think now this must be clear. Please go through the video again if this was complex, because maybe some people may find this question a bit tough, as we have some complex data structure and some complex dynamic programming operations. Yeah.